जयंतिया हिल्स, खासी हिल्स। हेलो,
तो ये कर दे रहा था।
आप इसमें सारा कर सकते हैं सर।
अच्छा सुनिए, अभी करें, हमको स्टार्टिंग करना है।
स्टार्टिंग करने से पहले आप इसको स्क्रीन शेयर मत कीजिए। आप स्टार्टिंग करने से पहले इसको आप स्क्रीन स्टॉप कर सकते हैं। ये आप दिख रहे हैं, आप दिख रहे हैं, आप बोल सकते हैं इनको कि हम ये करेंगे वो करेंगे।
गुड मॉर्निंग सर।
गुड मॉर्निंग सर। इसमें
देखते कैसे करेंगे।
सर इसमें कैमरा नहीं करें। इसको क्या करना है, इसके बाद आपको कोई भी एक साइड चाहिए ना, मान लो इसको ले लिया आपको, इसे ले लिया जो लिखना है अगर हिंदी में लिखना है, अगर हिंदी चाहिए तो बाद में आपको राइट साइड किया जा सकता है, जो आपका स्लाइड को आ जाएगा, भी लिख सकते हैं, इससे भी लिख सकते हैं, नीचे लिया अगर अगर आपको नहीं है तो देखिए बस यहाँ ये कर देना, ये समाप्त कर देना, हमारा ये वैसे समाप्त हो जाएगा, हम स्लाइड अपने दिक्कत है ये दिक्कत स्लाइड आपको जैसे जैसे आगे 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 करना है, लेकिन घबराना नहीं है, धीरे धीरे आराम से हो जाता है, ठीक है। ये हो आगे आगे भी नहीं जाएगा, कुछ नहीं जाएगा, ये काम करेगा इसके लिए तुरंत अगर इसको आगे करना है तो आपको ये आगे करना पड़ेगा, ये करके आपको आगे दिखाई देगा, ठीक है। नया फोल्डर में जाना आपको कोई कुछ नहीं जाना, आपको वापस आ जाना है, तो आप यहाँ से लगा दीजिए साइड में आ जाएंगे, और यहाँ से फिर यहाँ आ जाएंगे, और नया फोल्डर करना है तो आपको ये बंद करना पड़ेगा, ये बंद करना है, अब इन से बंद कर सकते कोई भी बाद में कोई आपकी तरफ से सुनना तो अभी कुछ स्लाइड करके जो हमें हो गया तो अगले साथ खुला रहेगा मान लीजिए कि यहाँ इधर कोई नहीं कर रहा है तो ये करनी शुरू होता है इसको भी ये बात हम करने की कर सकते हैं लास्ट स्लाइड पर इधर भी चलो इधर भी इधर इधर अभी हम करने का नहीं जब अगर लाइट चली जाती है तो आप पैरेलल ओपन करके रख दो आप वहीं से भी काम करा सकते हैं
गुड मॉर्निंग सर।
गुड मॉर्निंग टीटू जी, स्टार्ट करो ना।
हाँ हाँ सर।
अभी स्क्रीन बोर्ड पे नहीं लोगे क्लास?
हाँ बोर्ड ले लेंगे सर, वो उसको थोड़ा एडजस्ट कर लिया।
अभी बोर्ड दिखाई नहीं दे रहा, आप दिखाई दे रहे हो, मैं
अच्छा
नहीं दिखाई दे रहा, इधर कैमरा हो
तो इसमें बोर्ड दिखाई नहीं दे रहा है स्क्रीन में। ठीक है सर, ओके सर, हम देखते हैं आपको फिर कॉल करेंगे।
टीटू जी कर ही नहीं पा रहे हैं। ऐसा नहीं हो पा रहा सर, पता नहीं।
भी नहीं किया। टीटू जी अलाउ भी नहीं कर रहे हो आप, कोई जुड़ रहा है तो। 3 ही जुड़े हुए हैं। हाँ, और बोर्ड भी टाइम हो चुका है ना एक्चुअली। हाँ तो स्टार्ट कर दो, काफ़ी टाइम लगेगा ना वेव ऑप्टिक्स में तो। नहीं, एडमिट ऑल एक बार कर दिया ना, ओपन टू ऑल करना है। हाँ, ओपन टू ऑल किस में है सर?
उसमें नीचे होगा सर होस्ट कंट्रोल।
नहीं नहीं, होस्ट कंट्रोल में जाइए।
होस्ट कंट्रोल में फिर सबसे नीचे
होस्ट
लिखा है
कंट्रोल में नीचे नीचे है ओपन टू ऑल। होस्ट कंट्रोल, हाँ होस्ट कंट्रोल में जाइए। हाँ, होस्ट कंट्रोल में नीचे जाइए, ओपन टू ऑल होगा। हाँ, सेटिंग में ही है। मिला है ना? हाँ, कॉल कंट्रोल में ओपन टू ऑल करो, नीचे आ रहा होगा उसमें। किसका लिंक चाहिए? वो मिल जाएगा, चालू ही नहीं हुआ। होस्ट नहीं मिला। आ रहा है यार, आप तुम देख नहीं पा रहे हो। चलो अलाउ कर देना आप बीच बीच में। अभी सर का वो स्क्रीन शेयर करो, बोर्ड वाला। सर को बोलो क्लास चालू करने के लिए ना, आप अलाउ कर देना जो भी रिक्वेस्ट आए। अभी बोर्ड नहीं दिख रहा है। आपका स्क्रीन नहीं दिखाई दे रहा है सर। गुड मॉर्निंग सर, आपकी आवाज़ आ रही है लेकिन आपका स्क्रीन नहीं दिखाई दे रहा है। हेलो टीटू जी, टीटू जी आप मेरे को सुन पा रहे हैं? हेलो, इनसे आप ले लोगे क्या?
क्या सर?
वेव ऑप्टिक्स
क्लास आज
इनसे हो नहीं पा रहा है। स्क्रीन शेयर नहीं कर पा रहा हूँ।
कोई कंप्यूटर टीचर नहीं है
होगा लेकिन चलो चलो अंदर चलो, टाइम हो गया। व्हाट फॉर यू आर वेटिंग? सर नहीं हो पा रहा है तो मैं मेरे यहाँ से चालू करवाऊँ? नहीं, एक्चुअली ऑल आर वेटिंग, एसी सर इज कॉलिंग ना, और आप अलाउ भी नहीं कर रहे हो, अभी 6 ही लोग जुड़े हैं। कोई एफ सी कंप्यूटर टीचर नहीं है क्या आपके यहाँ?
हेलो हेलो।
हाँ आपकी आवाज़ आ रही है,
हाँ सर,
यू आर
सुटी।
ऑडिबल।
हेलो सर, लिसनिंग।
यस यस, यू आर ऑडिबल, प्लीज कैरी ऑन,
या
प्लीज शेयर द
ओके।
स्क्रीन।
Okay, good morning, dear students. Today, our topic of discussion, an important chapter, that is wave optics. First of all, overview of the chapters. Some topics. What are the topics we have to read? The topics are: number one, little bit idea of wavefront, then Huygens principle, then reflection of light based on Huygens principle, refraction of light based on Huygens principle, and behavior of wavefront in case of mirror, lens, prism, coherent sources, interference, condition for certain interference, Young double slit experiment, diffraction, and difference between interference and diffraction. So previously our syllabus is quite longer one, but now it becomes quite short. So you see, we can start little bit history behind wave optics. That wave optics idea come from where? Initially, up to 1850, up to that time, everyone believe about particle nature of light. Everyone believe about particle nature of light. But whenever Thomas Young, Christian Huygens, they put forward some experiment on interference, diffraction, then it is found that with the help of particle nature of light, it is not possible to explain. That can be explained a new theory that is called wave theory. And previously, it is believed that light in the denser medium is quite bigger. That means quite more with compared to rare medium. But whenever wave optics come into existence, then it has been found that the speed of light is more in case of rare medium with compared to denser medium. That means, what does it mean? Uh, if speed of light in vacuum, that is 3 into 10 to the power 8 meter per second, but in case of glass medium or in case of water medium, it will be less. So it can be proved by wave optics. So wave optics having more validity compared to ray optics. That means ray optics up to 1850. And what about the Newton idea about particle nature of light? That idea little bit different from wave optics. So now we'll come to the point that what is wavefront. All right. So dear students, you see wavefront. A wavefront means you can think that so many particles are there. Suppose in your hand, there is 100 more particles are there. If all the particles, suppose in the same line, that means you can say that all the particles are in the same phase. So whenever all the particles are in same phase, then we can say that all the particles means locus of all the particles are in the same phase. That is called wavefront. So here in the slide, you can see that a wavelet is a point of disturbance due to propagation of light. A wavefront is the locus of points having same phase. So same phase means the state of the particle is same. So that is called wavefront. Now the line which is perpendicular to the wavefront, that is called ray. So there are three types of wavefront. Number one, spherical wavefront. Number two, cylindrical wavefront. And number three, plane wavefront. So spherical wavefront, cylindrical wavefront, and plane wavefront. So spherical wavefront, how it will be produced? Cylindrical wavefront, how it will be? Plane wavefront, how it will be? The cylindrical wavefront means, spherical wavefront means whenever wavefront produced from a point source. Suppose if when light passes through a point, then it will produce a wavefront which looks like a sphere. And all the points on the surface of the sphere are in same phase, you can say that. So about spherical wavefront, you remember that the disturbance or wavefront, whatever it will be produced, that will be produced from a point source. Now, if you consider no, I will not consider the point source, I will consider the line source. That means slit type of source you have to use. Then when light passes through the slit, then it will produce not spherical wavefront, it will produce cylindrical wavefront. That can be seen in the second diagram. Whatever screen I have shared, you can see that first one is the spherical wavefront and second one is the cylindrical wavefront, the shape of the wavefront like cylinder. So you are getting my point, students? You see that wavefront means locus of all the points vibrate in the same phase, and there are three types of wavefront. One is the spherical wavefront, one is the cylindrical wavefront, and remaining one is the plane wavefront. So plane wavefront is what? Plane wavefront may be spherical, may be cylindrical, but if the distance of the source is far from the point, then we can say that is our plane wavefront. All right, if you place the screen apart from the source, then whatever the wavefront will produce, that is plane wavefront. So first, in the wave optics, you will read what is wavefront, what are the types of wavefront, and why wave optics having a lot of validity compared to ray optics, because with the help of wave optics, some phenomena like interference, diffraction, and polarization that can be explained with the help of wave optics, but it cannot be explained with the help of ray optics. So dear students, remember this point that ray optics can explain some phenomena, that is reflection, refraction, dispersion, but with the help of wave optics, we can explain whatever the topic explained by ray optics, that also, that means reflection, refraction, dispersion. Along with this, some additional phenomena can be explained with the help of wave optics, that is interference, diffraction, polarization, which cannot be explained with the help of ray optics. So this is very important point, that wave optics having more validity compared to ray optics. Now, we have got wavefront, we have got three types of wavefront, and the wavefront, the type of wavefront are spherical wavefront, cylindrical wavefront, and plane wavefront. Spherical wavefront, cylindrical wavefront, and plane wavefront. So these are the three types of wavefront. Now, about the wave theory, the main principle will come from that Huygens principle. That Huygens principle is what? Huygens principle, we have to read. That hygiene principle is the main principle regarding wave optics. So let us see what is hygiene principle. Next, second topic of us after wavefront, we'll go to hygiene principle. So hygiene principle actually is a kind of assumption that how geometrical construction of wave can be possible. How geometrical construction of wave can be possible. So geometrical construction, you see, suppose a wavefront is produced, then in wavefront, you can see a small sphere in the wavefront. You can see this is a small spherical sphere, small sphere, small sphere. So in the spherical wavefront, so many points he has considered. And these points are all are the point are the source of secondary wavelet. These points are all are the source of secondary wavelet. So first Christian hygiene principle, the point is like that. First principle is that each point on a wavefront acts as a source of disturbance. Or you can say that means each point of the wavefront is the source of light. Small point is a source of light. So this is first principle of hygiene. All right, first assumption of hygiene. Now, what is the condition for new wavefront? That new wavefront at any time, that letter can be obtained by taking forward envelope of the secondary wavelets at that time. That means if we draw the tangent, then we can see that a secondary envelope can be produced, and this is becomes the forward envelope. So two assumptions for hygiene principle. One is the first one, each point of the wavefront is the source of secondary wavelet, and second one is that new wavefront at any time becomes the position of the new wavefront. All right. So this hygiene principle you have to read. In the textbook also the two assumptions are there. I think you can remember these 2 points. That each point of the primary wavefront is the source of secondary wavelet, and new position of the wavefront whenever we draw the tangent on that wavelet. So this is called hygiene principle. Here one point is written there in the note. You see, backward wavefront is rejected. Why backward wavefront is rejected? Because backward wavefront intensity is quite less. That's why it can be rejected. So this is the point that backward point can be rejected. Now you see, when hygiene principle come into existence, then it can be explained the law of reflection and refraction. That is very important topic, because most of the time you to observe that reflection and refraction part used to come during exam. So students, you read this topic. That means what is reflection and what is refraction. All right. So laws of reflection that can be proved previously with the help of particle nature, and now we can explain it with the help of wave nature. So another important point is that after the briefing of this wave optics, I will share some questions with you and we'll discuss that question along with you. I want to know your comment about the questions, and after that, whatever the answer you can see in the next slide also. That means you have to prepare for that. So first you listen, that means what are the overview of these chapters. So hygiene principle from the first slide, that means wavefront. After the wavefront, then we can say that there will be different types of wavefront. Then different types of wavefront, then we can say that means hygiene principles. So these are all the points are required for us. So next, our main point is law of reflection on a plane surface. So dear students, you see, a plane surface is considered, that is our xy. Here, a wavefront. What kind of wavefront? Plane wavefront. The plane wavefront is AB. So whenever plane wavefront is AB, incident on the surface, then it will produce another plane wavefront whenever it will be reflected from the surface, that becomes CD. So AB is the incident wave front and CD is the reflected wave front. So from here, we have to prove that as law of reflection. So what are the law of reflection? Anyone? Law of reflection is what? Law of reflection, anyone can say? Student, if you are listening, then you can just say me what are the law of reflection. Law of reflection, I'm asking about law of reflection. Law of reflection, you are audible, students? Students, are you audible? Hello, student. Are you audible? I'm asking about uh, law of reflection. Okay. Law of reflection, I'll just repeat these two. There are two laws of reflection. First of all, first one is the incident ray, reflected ray, and the normal all are lies at the same plane. And second one is that uh, incident angle equal to the reflected angle. So these are the two laws of reflection. So this law can be proved with the help of hygiene principle. With the help of hygiene principle. So once again, you see the diagram. In the diagram, a plane surface is there. In that plane surface, AB is the incident wavefront and CD is the reflected wavefront. So simply diagram you have to remember. After drawing the diagram, then you see that means two ways you can prove. Two ways you can prove. The first one, you can take this triangle ABC and another triangle is ACD. So from that triangle, you see AB makes with the plane surface one angle that is I and CD makes an angle that is R. So if you can prove I equal to R, then reflection theory can be fulfilled. That is called law of reflection. That is called law of reflection. So here one numerical part is there, mathematical part is there, that T equal to EF by C plus FG by C. So from right angle triangle, EF equal to AF sin I and FG equal to FC sin R divided by C. After that, whenever we enlarge it, then T becomes that. So for that ray, we can say that light from different parts of the incident wavefront, the values of AF are different, but light from different points on the incident wavefront should take the same time to reach the corresponding point on the reflected wavefront. So T should not depend upon AF. This is possible only if sin I minus sin R equal to 0. If sin I equal to sin R, then angle I equal to angle R. So this one called the angle of incidence equal to the angle of reflection, and that is proved by hygiene principle. That initially we know that ray optics also ray optics also that light whenever travels from one medium to another medium, that means it falls from air to glass medium, then what will happen? That it will be reflected. And whenever it will be reflected, that incident ray, reflected ray, and the normal all are lies at the same plane, side by side. That incident angle must be equal to the reflected angle. That is called law of reflection. All right. So you read this. So wavefront, types of wavefront, Huygens principle, then law of reflection. Then will come next part, Huygens principle, with the help of Huygens principle. Second proof is that law of refraction. Okay, the law of refraction, once again, our previous knowledge about law of refraction is, what are the laws of refraction? That sin I by sin r, in the short form, sin I by sin r, a constant. If sin I by sin r a constant, we can say that ratio of the sine of the incident angle to the refracted angle always a constant, and that constant is called refractive index of the pair of media. So whenever sin I by sin r equal to constant, how we can prove it? Once again, the same procedure. Diagram is little bit same, different. In the reflection, the plane wavefront just strikes on the reflecting surface and it will be reflected back. But here we consider two medium, or light homogeneous medium, that light can travel from one medium to another medium. It will be not bounce back, it will be enters through the other medium. So you see that when light goes from rare medium to denser medium, as per our idea, we know that it will be bent towards the normal. And whenever it will be bent towards the normal, then with the normal, whatever the incident ray makes an angle, that is incident angle, and whatever the refracted ray makes an angle, that is called refraction angle. But here, whenever Huygens theory of blue going to explain, then we consider a plane wavefront. AB is the plane wavefront. So AB is the plane wavefront. In the plane wavefront, whatever the three lines you are observing in blue line, they are called ray, because the definition of ray is that perpendicular line on the wavefront is called ray. So plane wavefront just strike on the surface XY. XY is the boundary between rare and denser medium. Okay, so XY is the boundary between rare medium and denser medium. So whenever XY becomes the boundary between the rare medium and denser medium, then light will travel, that plane wavefront will travel from rare medium to denser medium. Here AB is the incident wavefront and CD is the refracted wavefront. Okay, so if AB is the incident wavefront, CD is the refracted wavefront, then once again, what is the time or that plane wavefront whenever it travels from one medium to another medium? That in the slide you can see T equal to, like previous reflection theory, EF by C, FG by P. C is the speed of light in the rare medium, P is the speed of light in denser medium. Again, we have to enlarge it, then EF means AF sine of I, and FC sine R divided by P. Then we expand it, that two moments you have to write that rays of light from different parts of the incident from the values of A. But light from different points on the incident wavefront should take the same time to reach the corresponding point on the reflected wavefront. So if it will be like that, then sin I by sin C is sin I by C minus sin R by V equal to 0. If it is 0, sin I by sin R equal to C by V, then you know that the ratio of the two speed of light in two medium, that is called a constant. That constant is called refractive index of the medium. If sin I by sin R equal to mu, then you can say that the refraction theory can be fulfilled by Huygens principle. So students, wave optics can explain not on the interference and diffraction, it can successfully explain whatever the topics explained by particle nature also, that is reflection and refraction. So these two theory we have to read. Okay. So again, overview of the wave optics. Whenever you're going to read the wave optics, first you go through wavefront, different types of wavefront, or hygiene principle. With the help of hygiene principle, law of reflection and diffraction. Okay, dear students, I want to a little bit make conversation with you. Uh, in your uh, screen, my screen is observing. You can observe whatever the screen I am sharing with you. Anyone?
Yes, sir.
Okay,
Sir,
good.
आपका आवाज डबल हो
Okay,
रहा है नेट ऑफ
who is now saying yes, sir, from which Gen V? You are from which Gen V? Morigaon, good. So students, you see wave optics में कहाँ से पढ़ना है, फिर once again you just listen it. Wave optics को हम लोग को एक idea किया है, wave optics is a little bit tough chapter. It is not possible, but it is not like that. Wave optics is such a chapter from where so many only little bit topics you have read, but questions common questions used to come. तो क्या पढ़ना है? First पढ़ना है wavefront, then types of wavefront, and hygiene principle with help of hygiene principle, that law of reflection and refraction. After that, you see some diagrams I will show you. Some diagram. A diagram क्या है? That when a plane wavefront passes through a concave mirror, convex lens, concave lens, what are the type of wavefront? देखा ना, प्लेन वेव फ्रंट AB जस्ट स्ट्राइक्स ऑन द कॉनकेव मिरर से क्या होते हैं, मिरर से रिफ्लेक्शन होते हैं, रिफ्लेक्शन होके फिर वेव फ्रंट का स्ट्रक्चर बन जाता है स्फेरिकल टाइप ऑफ स्ट्रक्चर. जैसे AB इज द प्लेन वेव फ्रंट इंसिडेंट ऑन द मिरर एंड CD बिकम्स द स्फेरिकल वेव फ्रंट. फिर हम लिया है कौन सा मिरर, कॉन्वेक्स मिरर से देखो तो प्लेन वेव फ्रंट AB and CD becomes our reflected wavefront. Again लिया है convex lens light can pass because there is refraction. AB is the plane wavefront, CD is the refracted wavefront. And for concave lens, AB is the plane wavefront, CD is the refracted wavefront. So dear students, you remember these four types of wavefront that can be passed from mirror and lens. Okay, plane wavefront just right. After that, the pattern of the wavefront becomes changed whenever it passes through the different lens or mirror. So these questions only for your 1 mark question. That 1 mark question you read how to draw. If you having pencil and paper, you can practice it. That means when plane wavefront passes through the mirror, what are the structure can be formed. Then whenever it will be reflected back, how the wavefront looks, reflected wavefront. So AB is the incident wavefront, CD is the reflected wavefront in the first two diagrams. And in the second two diagram, AB is the incident wavefront, CD is called refracted wavefront because in the lens, refraction is possible. Okay. So another is diagram part only. And another two diagrams is they are referring you whenever it passes through the prism, how it will look like. So passes through the prism, the structure is a little bit different. Okay. AB is the incident wavefront, CD is the refracted wavefront. So that is in general part. In general part means that can be related with ray optics and wave optics. Now we will completely enter in another part that is totally new. Okay. So all of you related with the sources of light. I can say the new sources of light, that is coherent sources of light. So what is coherent sources of light? Condition of coherent sources of light. If you know the conditions, you can give the definition. What is coherent sources of light? You see, Coherent sources of light are those of light which emit light of same wavelength, same frequency, and same phase or having constant phase difference. If a light can maintain these conditions, then we can say that it is a coherent source of light. So coherent source of light means when light having this characteristic. What are the characteristics? They having same frequency because two sources of light, suppose two candles have used in from the same place, and that can be just passes through a two slit in the same plane. Then what about the sources after that produced? That is called coherent sources. Why it is called coherent sources? Because number one, it having same frequency. Number two, it having same wavelength and having constant phase difference or phase difference between the um, two is zero. The constant phase difference after that same wavelength, same frequency, these are the characteristics of coherent sources. If it will be not maintaining this, then it is called incoherent sources. The coherent sources conditions are important. Coherent sources. That coherent sources means light having same frequency, same wavelength, and having constant phase difference in between them. Okay. So after coherent sources, interference of light. Next theory is interference of light. So interference of light is the new phenomenon for you because interference of light, the person, the scientist behind it is nothing but Thomas Young. He performed a beautiful experiment that is called Young double slit experiment. Young double slit experiment. So interference of light is what? Yeah, you know that reflection, one word meaning is bounce back of light. You know the reflection, one word meaning is bending of light. Interference का meaning क्या है? Anyone? Interference का meaning? Interference क्या है? Interference means, students, you see, that is called superposition of light. Interference means superposition of light waves. Superposition of light waves means that two light waves, if they are coherent. Coherent means constant, having same wavelength. After that, same frequency. If they travel in the same medium, in the screen, they will be superposed upon each other. And due to that superposition, a pattern has been formed that is called interference pattern, and the phenomena is called interference of light. That means when two light waves just interfere or superposed upon each other, then there is a redistribution of energy. And redistribution of energy whenever occurs, then it will be observed that redistribution energy when it was, a new pattern has been formed on the screen that is called interference pattern, and the phenomena is called interference of light. The phenomena is called interference of light. So interference of light means the waves are with same speed, wavelength, frequency, time period, equal amplitude, traveling in the same direction with constant phase difference. And if it will maintain it, then after the superposition of light waves, whatever the pattern has been formed, that is called interference pattern, and the phenomena is called interference of light. Initially, we remember that how theory of interference fringes, but now it is no need. Only one formula you have to remember, that what is the final amplitude after the superposition of two light waves. That is A equal to over A square plus B square twice AB cos of phi. Or simply you can say that intensity of light becomes I equal to A1 square plus A2 square plus twice A1 A2 cos of phi, where phi is the phase difference in between them. So this is the interference of light. So interference of light whenever you go, and you must know interference कैसा देखने को कैसे होता है interference. So now you see interference of light wave. Interference of light wave means this is a wave, green one, red one, blue one. All three are superposed on the screen. And whenever superposed on the screen, some bright band and dark band that can be produced on the screen. And this dark band, bright band, and along with the pattern, this is called interference pattern. And whenever interference pattern has been formed, then there will be redistribution and of energy. Then each and every part we have got some at some point that there some brightness is there. At some point there will be darkness is there. Whenever brightness is there, that is called bright band. Whenever darkness is there, that is called dark band. That means interference pattern में क्या होता है? Dark and bright band, they will be coexist and each having equal length. सबका length कितना होना है? Equal होना है. Whenever they become equal length, then we can say that fringe width is same in case of interference of light. Fringe width is same in case of interference of light. So interference is an important phenomenon. First you will read what is the definition of interference of light. Then one mathematical formula. Mathematical formula means intensity that proportional to the square of the amplitude. And what is the final intensity after superposition of light waves? Then you can say that I equal to A1 square plus A2 square twice A1, A2 cos of phi. A1 and A2 are the amplitude of two different waves. That means they are called coherent sources of light wave. And after superposition, there will be a redistribution of energy. So interference of light can be observed by one scientist is called Thomas Young. So this is the theory of interference. So theory of interference, no need to go for derivation. Simply definition, and after that, what is the resultant intensity, and then will come to constructive interference and destructive interference condition. Okay, constructive interference and destructive interference. Constructive means where bright band has been formed, and destructive means where dark band has been formed. So you see, condition for constructive interference and condition for destructive interference. And एक तो ऊपर में लिखा है I equal to A1 square or A2 square A square plus B square twice AB cos of phi. Intensity और amplitude का साथ relation क्या है? Amplitude intensity is the square of the amplitude of the wave. Okay. The condition for constructive interference, condition for constructive interference, condition for destructive interference. Last board exam में हम लोग को एक क्वेश्चन आया था ना, what are the condition for constructive interference, what are the condition for destructive interference. The condition for constructive interference here it is given that tan into lambda, and condition for destructive interference that is will be twice n plus 1 lambda by 2 n plus half lambda. You can say what is lambda? Lambda means wavelength. What is n? N is an integer. Its value is 0, 1, 2 for constructive and destructive interference. And del is the part difference. This is part difference. So part difference equal to n into lambda. Just a minute. Sir, I am having class. I will talk to you after some time. Okay, sir. So, okay, sorry, students. Unimportant call this. No? Once again, interference of light means definition you have to read. After that, you will read what is the how it will be formed, and this relation I equal to a square plus b square twice ab cos of phi, and condition for constructive interference, condition for destructive interference. This is important. Condition for constructive interference, that path difference equal to n into lambda, and condition for destructive interference, path difference equal to twice n plus 1 lambda by 2. Then path difference means how whenever light goes to each one point, then what is the difference between their path? If we consider in the Young double slit experiment, that means from one point to another point for two sources of light, if you consider, then what is the difference of their path? That is called path difference. So path difference equal to जब n lambda होता है, that is called constructive interference की condition. And destructive interference होने से कैसा क्या होगा? That is equal to twice n plus 1 lambda by 2. And in constructive interference, the intensity becomes maximum. I maximum equal to a plus b whole square, or I minimum equal to a minus b whole square. So minimum में minus, maximum में plus. Whenever superposition of light wave occurs, two light waves one becomes superposed and they become intensity becomes maximum. And whenever there will be subtraction between the two, that is called a minus b whole square. That is the condition for intensity is minimum. The maximum intensity for sum of minimum intensity for minus from one amplitude to another amplitude square. So these are the two conditions for a interference, constructive interference and destructive interference. So this condition is important. So first we would maybe ask what is the condition for constructive interference, what is the condition for destructive interference. Now, Young double slit experiment एक बार देख लो, that light passes from a source, then single slit means one gap is there. Then whatever the wave front produced that passes toward the two slit, then it goes double slit. After that becomes coherent, and whenever coherent source on the screen, there is a superposition of light. And after the superposition, you see there are some band is produced. Band means dark band and blue band here. No, dark band and blue band. So dark one is called minimum intensity, and blue one, whatever looks like bright, that is called maximum intensity. What is the condition for dark band? Constructive or destructive? It will be destructive. तो destructive का condition क्या है? Destructive का condition है path difference equal to twice n plus 1 lambda by 2. And constructive blue color, whatever you observe on the screen, इसका condition क्या है? Condition equal to n into lambda. Simple two point. So constructive interference and destructive interference. Then in your mind it becomes that what is path difference? You see next second diagram में S1 and S2 split, no? So S1 to P and S2 to P. So S2P minus S1P is called the path difference. All right. Whenever light passes, that means how much distance covered by from the point S2, how much distance covered from the point S1. S2P minus S1 is called the del. Del is nothing but path difference. And calculation का बात लिखा गया है that S2P minus S1P, that path difference equal to y small d divided by capital D. So y मतलब distance, y मतलब distance from O to P, center से P का distance कितना है? That is your distance. And small d is the distance between the two slits, S1 or S2 का distance कितना है? That is the small d. And capital D is the distance of the screen from the plane of the screen. Okay. So this is your path difference, calculated form of path difference. The path difference equal to yd divided by d. Now by that one, we're going to find what is fringe. So interference of light, first how interference of light occurs. After that interference of light, how it will be look like. In the screen we have observed that some dark or bright band is there. Then Young double slit experiment, but now today's calculation not record, only final formula is required for you. So final formula means what is the expression for fringe width. So fringe width you see, expression for fringe width denoted by the symbol beta. Beta equal to two distance का जो difference है that is equal to beta. So constructive और destructive interference का fringe width same है. That means इस diagram में अगर हम आएंगे, देखो dark band और bright band दोनों का width same है. That is called fringe width. What is fringe width? The distance between two consecutive dark band or distance between the two consecutive bright band is called the fringe width. That means what is the width of the fringe? What is the expression of fringe width? That is calculated by hygiene. And hygiene, as per hygiene, the calculated value of fringe width beta equal to d lambda by d or dark band के लिए भी same, that is d lambda by d. Whenever the Young double slit experiment performed in air, then it is observed that the fringe width equal to d lambda by d. D lambda by d means capital D is the distance of the screen plane of the slit. Lambda is the wavelength of light used, and small d is the distance between the two slits. Okay, so whenever you increase capital D, then fringe width will increase because it is directly proportional. Whenever you increase the wavelength of light, then also beta will increase. But whenever you increase the distance between the two slits, then beta will decrease. That means fringe width will increase or decrease based on these three parameters. These three parameters are the distance of the screen from the slit, wavelength of light used, and distance between the two slits. So, dear students, if you are listening properly, just it is an important formula for the interference of light, that is beta equal to d lambda by d. So beta means fringe width, capital D means distance of the screen from the plane of the slit, and lambda is the wavelength of light used, and small d is the distance between the two slits. This is the final expression for fringe width. And condition for constructive interference, path difference equal to n lambda. Condition for active interference, path difference equal to twice n plus 1 lambda by 2. What is interference of light? How it formed? What is the intensity of light waves? Resultant intensity? What is the condition for constructive interference? What is the condition for destructive interference? And finally, what is the expression for fringe width? So, इसको पढ़ना है. You have to read this interference pattern. After intensity interference pattern, what about the intensity observed in the skew? If you draw in the board, it looks like that. That all the part having same amplitude. So this is a wave. In the interference pattern, we observe that when peak occurs, that is constructive, or a peak become down, it will be lies on the axis. That is called destructive interference. That means destructive interference and constructive interference, they in observed in the intensity distribution curve. Intensity becomes maximum for constructive interference, and intensity becomes minimum for destructive interference. So इसको drawing part is important. ठीक ना? So expression for fringe width is equal to d lambda divided by d. Now another question in the first keyboard we have observed that if the Young double slit experiment performed in water, is there any changes of fringe width? your reply should be yes, it will change. How it will be changed? If refractive index of water is mu, then beta should be divided by mu so that its width becomes reduces. So whenever that means young double slit experiment performed in water, that means in a medium where refractive index is more than air, then fringe width become reduces. So beta dash equal to beta by mu. Whatever the your fringe width, that should be divided by refractive index of that medium. That is one point, cases. And second cases is that angular width theta equal to lambda by small d. Lambda is the wavelength, small d is the distance between the two slits. These 2 points you have to remember for interference of light. The complete interference of light, whenever, once again overview, that first what is interference of light, what is the condition for interference of light, what is the resultant intensity of interference of light, condition for constructive interference, condition for destructive interference, expression for fringe width, then we'll go for whenever it is performed in water, what are the fringe, how fringe width change, and what are the angular width. So this is the complete form of interference of light. So students, now we'll come to the last topic of this chapter, that is diffraction, and after that we'll go through the question bank. So last topic is diffraction of light. ठीक ना? तो light का जितना phenomena है देखो. First one, reflection of light means bounce back. Refraction of light means bending of light. Then we got dispersion of light, splitting up of light. Then wave optics explain किया. Interference of light, which is not possible to explain with the help of ray optics. Interference means superposition of light wave. Now, diffraction of light. So diffraction of light is also a kind of bending of light. That means light will be diffract. Light will deviate the rectilinear propagation of light. So what is diffraction of light? Diffraction of light, you see, when light, suppose, passes through a narrow slit. That means if it will be compared with the wavelength of light, and it can be seen in the laboratory also. The filament bulb can be observed by two blades, and you are observing, your eyesight is towards the in between the two blades, and you can see that filament bulb, whatever the filament of the bulb that becomes broad. So it is a kind of diffraction. So what actually happens in case of diffraction? So diffraction of light is the phenomenon of bending of light around the corners or an encroachment of light within the geometrical shadow of the opaque obstacle, that is diffraction. Or if you want to say that diffraction of light is the bending of light whenever light passes through a narrow obstacle. All right. So whenever light passes through a narrow obstacle, then you see some amount of light in the enters in the geometrical shadow region. Here also some amount of light enters in the geometrical shadow region. Here also. So whenever light enters in the shadow region, that means what? Light is different from the rectilinear propagation of light. That means light is not traveling in a straight line. There will be bending, and that bending is the kind of phenomenon that is called diffraction of light. So diffraction of light is a phenomena where we observe that light enters in the geometrical shadow region. Whenever light bending and it passes through a narrow obstacle, some amount of light enters in the geometrical shadow region, that is called diffraction of light. The diffraction of light is one important topic, but no mathematical formulation needed. You remember it. The diffraction of light, only quality discussion is needed. What is diffraction of light? What are the conditions for maxima and minima? And what is the fringe width for central fringe? And what are the how intensity distribution curve look like? So let us go to the second slide of diffraction. So diffraction of light due to a single slit. Single slit means एक ही slit हम लोग लिया है. Diffraction of light not occurs from double slit. Double slit में होता है interference. But single slit में क्या होता है? That is diffraction. If the size of the slit is quite less, it is comparable to the wavelength of light. So in the diagram it is observed that whenever light ray passes, that is plane wave front passes, then diffraction occurs, and at no point it is written bright. O point में bright लिखने का meaning क्या है? That means central fringe becomes brighter one, where intensity is maximum. All right. Central fringe is maximum brightness occurs. Then, if it is be not plane wavefront makes an angle, so that angle is theta 1, then diffraction pattern will be changed. In this way, diffraction occurs for different conditions, and finally calculated value of central bright fringe, that is beta equal to twice d lambda by d. In the interference pattern, we have got that beta equal to d lambda by d, but here beta equal to twice d lambda divided by d, where d is the distance of the screen and lambda is the wavelength of light and small d is the distance of the slit. That means how much is small d? Then small d is the distance between A and B. And what is the capital D? Capital D is the from the plane of the slit, how much apart the screen has been kept. And lambda is the wavelength. So sometimes used to come, the question used to come, that means if you have monochromatic light replaced by or white light replaced by monochromatic light, how diffraction patterns look like? So these are the common questions for interference or diffraction. What are the coherent sources supplied? So many points we have to discuss here, and you will get these questions. So finally, you can say that whenever diffraction occurs, they are at some point minima occurs, at some point maxima occurs. Minima का condition है क्या? That means n plus half lambda, और maxima का condition, minima का condition n into lambda, और maxima का condition है n plus half into lambda. That is the condition for maxima and minima equal to n into lambda. So interference and diffraction, there is a correlation. What are the correlation? Interference also a topic of wave optics, diffraction also a topic of wave optics, but there is a difference. What kind of difference between interference and diffraction you see? Interference occurs due to the superposition of two light waves, no? But diffraction occurs from the secondary wavelength from the different part of the same wavefront. Fringes are generally constant. That means fringe with whatever you have got in interference, that is same width. But fringes are varying width in case of diffraction. All the maxima having same intensity in case of interference, but here maxima are varying intensity. Central fringe is quite maximum, and with compared to other secondary minimum, secondary maximum. There is a good contrast between maxima and minima. There is a poor contrast between maxima and minima in case of diffraction. So at last you can read this one. What is the difference between maxima and minima? So this is another point. The difference between interference and diffraction is that interference occurs from the two coherent sources, or here it is written, is due to the superposition of two different waves rays coming from coherent sources. And diffraction is due to superposition of secondary wavelength from the different part of the same wavelength, same wavefront. Fringes are equal in case of interference, but in case of diffraction, fringes are of varying width. In case of interference, all maxima having same intensity, but in case of diffraction, the maxima are of varying intensity. And at last, there is a good contrast between the maxima and minima. And in case of diffraction, there is a um, poor contrast between maxima and minima. So this is the difference between interference and diffraction. So dear students, once again, if wave optics, whenever we start from the beginning up to the last of this topic, what we will go through? We will go through the part. First one, what is wavefront? What are the different types of wavefront? So first point you can see what is the wavefront, what is the different types of wavefront. So in this way, then we'll go through the second point. Just a minute. Then wavefront, different types of wavefront, hygiene principle, refraction with the help of hygiene principle, refraction with the help of hygiene principle, two-mark question. These are behavior of wavefront in mirror, lens, and prism. These are diagrams. Then coherent sources. What are the conditions for coherent sources? Interference, condition for this point, condition for sustained interference. What are the conditions for sustained interference? Sustained interference means whenever interference pattern becomes fixed on the screen, that is called sustained interference. What are the conditions? Condition means two waves must be coherent, they must be having same frequency, same wavelength, and the slit also quite smaller, that means they are narrower. Whenever it can maintain the condition, the interference become fixed on the screen. This is the sustained interference. Then Young double slit experiment, condition for constructive and destructive interference, and expression for fringe width. And finally, diffraction, the maximum and minimum condition, fringe width condition for central bright fringe, and difference between interference and diffraction. So this is the overview of the chapter. Now we'll come to the point that is important part, that is called discussion of questions from wave optics. Some questions I have prepared for you. You can share with me. Just a minute. Okay. First, you see, number one, some MCQ questions in the first slide. First question is that which of the following phenomena demonstrate the wave nature of light? Anyone? Which of the following phenomena demonstrate by wave nature of light? Students, I'm just waiting for your answer. Which phenomena can be explained with the help of wave nature of light? Photoelectric effect, interference, emission of X-rays, Compton effect. Student, please your answer. Which phenomena can be explained with the help of interference? That means the answer is interference of light. Okay. The phenomena that can be explained with the help of wave nature of light, that is interference of light. Second point is that which of the following cannot be explained on the basis of wave nature of light? Second question. Which one of the following cannot be explained with the help of wave nature of light? Polarization, diffraction, photoelectric effect, interference. So the answer will be photoelectric effect. Okay. Next, number three, question number three. In Young double slit experiment, the fringe width will कौन सा होगा आंसर देखो increase if wavelength increases, decrease if slit separation decreases, increase if the screen distance increases, remain unchanged if the wavelength increases. Which one you answer? No, sir. The answer is increase if the screen distance increases. That is C, option C. The first one is wave nature can demonstrate all this topic that which of the following phenomena, that is interference. Second one is that which of the following cannot be explained with the help of wave nature, that is called photoelectric effect. And number three, whenever Young double slit experiment, the fringe width will, because we know that fringe width is beta equal to lambda by d. So beta is directly proportional to capital D. Here option C will be like that, that increase if the screen distance increases. Okay, because it is directly proportional. Then last 4 number MCQ from this slide. The intensity of bright and dark fringes are 4I and I respectively. What are the ratio of the amplitude of the wave? ये क्वेश्चन हमेशा आते हैं. The intensity of bright and dark fringe 4I and I respectively. So what are the ratio of the amplitude? A, B, C, D. The how to calculate, you see, intensity of light wave for bright and dark. और bright के लिए क्या होता है A1 plus A2 और dark के लिए क्या होता है A1 minus A2. Again A1 is the root over I1, A2 is the root over I2. तो root over 4I मतलब 2 और root over I मतलब 1. So whenever 2 plus 1 that is equal to 3 and 2 minus 1 that is equal to 1. So 3 to 1 is the correct answer. This one. The first one answer is interference, second one modulatory effect, third one increases if the screen distance increases, and fourth one 3 is to 1. Then next, if Young double slit experiment is performed in water, which of the following correct? Fringe width will decrease, fringe width will increase, there will be no change, fringe width will remain unchanged. Option A, B, C, D. Fringe width क्या होगा? Whenever Young double slit is performed in water, students, your answer. तो इसका आंसर है fringe width will decrease. It will be divided by mu, beta by mu, and fringe width will decrease. Next, what happens to the interference pattern of two slits S1 and S2 in the Young double slit experiment are illuminated by two independent but identical sources? That means two independent sources they have used, not a single source, two independent sources used. Then intensity of bright fringe is doubled, intensity of bright fringe becomes 4 times, two set of interference overlap, no interference pattern is observed. So, question number 6. Question number 6, देखो, whenever two independent light source we have used, then what will be the correct option? A, B, C, D. तो इसका आंसर एक बार देख लो. No interference is observed. No interference pattern can be observed whenever two independent sources have been used. We have to use one source, but that will be two slit passes through the two slit. Okay. Next, question number 7. Two light sources are said to be coherent if both sources of light emit light. That we already have discussed. No, they have same amplitude and phase. They have same intensity and wavelength, the same speed, same wavelength, and constant phase difference. कौन सा आंसर होगा? Two light sources are said to be coherent if both the sources of light emit light of same wavelength and constant phase difference. All right. So it should be same wavelength and constant phase difference. Next, a diffraction pattern is obtained by using beam of red light. What will happen if red light is replaced by blue light? Red light से blue light का क्या है? Wavelength कम है. तो जब ब्लू लाइट का वेवलेंथ कम है, रेड लाइट अगर रिप्लेस्ड बाय ब्लू लाइट तो क्या होगा? और ऑप्शंस आर band disappear, band become broader and further, no change takes place, band become narrower and crowded. So your answer is should be D. Diffraction band become narrower and crowded. Okay. So these are the some overview of MCQ type question, whatever used to come from this chapter. And next again, ascertain and reason-based question. Ascertain reason-based question, that means this is a logical thinking part question, no? That means if you have to think logically, then answer will comes out. First option A. Whenever first option your answer is A, whenever both the options are correct, but R is the correct solution of A also, then we can say that is A. Answer is A. B is both the options are correct, but it is not the correct explanation. R is not the correct explanation of A. And C is A is true, R is false. And D is A is false, but R is true. The चारों options में कौन सा options will be suitable for that ascertain and reason? We have to think logically and give our answer. The first question is, you see, in young double slit experiment, fringe width increases with the increase in the distance between the slit and screen. So fringe width for beta equal to d lambda by d. So d increases means fringe width will increase. And region में लिखा the fringe width is directly proportional to the wavelength of light. Here it is written that distance of the screen, and here region में लिखा wavelength value. So two are different point, but both are correct. So which option is matched with it? That is both A and R is true, and R is the correct explanation of A. So this is the answer of that question. Okay. So this is the answer of that question. That means in the question number one, if you think logically, that both the options are correct because fringe width directly proportional to lambda. And second one is that fringe width is inversely, fringe width is directly proportional to wavelength also, but it is not explain the SR term. So this is the option is B. Next, question number two. No interference pattern is detected when two coherent sources are infinitely close to each other. The fringe width is inversely proportional to the distance between the two sources. After the answer, students, you write in your copy, and after that you see whether your answer is correct or not. Question number two में लिखा है no interference pattern is detected when two coherent sources are infinitely close to each other. और रीजन में लिखा the fringe width is inversely proportional to the distance between the two sources. All right. Third point में लिखा interference pattern is made by using yellow light instead of red light. The fringes become narrower. And reason में लिखा in young double slit experiment, slit fringe width is given by beta equal to d lambda by d. This is number three, point number three. And number four, may you see, diffraction takes place all types of waves, mechanical or non-mechanical, transverse or longitudinal. Reason में लिखा diffraction effect is perceptible only if wavelength of wave is comparable to the dimensions of diffracting device. बोला है diffraction effect is perceptible if the wavelength of wave is comparable to the dimension of diffracting device. And last में लिखा है number 3. In young experiment, the fringe width for dark fringe is different from the white fringe. बोला है इसको width different है. And reason में लिखा in young double slit experiment, the fringes are performed with a source of white light, then only black and bright fringes are observed. In young double slit experiment में क्या लिखा? The fringes are performed with a source of white light. Then only black and dark fringes are observed. So question number 2, 3, 4 and 5 इसका आंसर एक बार मिला लो. देखो क्वेश्चन नंबर 2 का आंसर है ए, क्वेश्चन नंबर 3 का आंसर है ए, 4 is B, 5 is D. So these are the certain and reason based question from the chapter we can say. Finally, some of the question used to come like that. What are the conditions for sustained interference? So already I have discussed that sustained interference condition is that whenever two sources should be coherent and they should be zero from each other. What are the effective interference pattern? If suppose young double slit experiment occurs and condition is given, screen is moved away from the plane of the slit. Suppose D का distance करा दिया है. So whenever D will be more, then fringe of young double slit pattern में क्या होगा? Fringe width will become more. इसलिए separation between the slit is increased. So whenever separation small d increase, then beta will increase, fringe width will decrease. Width of all slit are doubled. Then no fringes pattern can be observed because job slit with become double, then fringes become disappear from the screen. So this type of question is to come uh, from fringe with pattern. Next. So नेक्स्ट क्वेश्चन देखो, ये हाइजीन प्रिंसिपल क्या है? व्हाट इज हाइजीन प्रिंसिपल? इसका साथ है येलो लाइट illuminates a single slit with 1 into 10 to the power minus 4 meter. Calculate the distance between the two dark lines on either side of the central maximum when the diffraction pattern is viewed on a screen kept 1.5 meter away from the screen. So dear students, whenever question used to come from diffraction chapter, suppose, then first लिखना है what is given in this question. Suppose lambda given 6,000 Armstrong means 6,000 into 10 to the power minus 10 meter. Single slit का width क्या है? That is equal to um, D equal to 10 to the power minus 4 meter. And screen capital D कितना रखा है? That is equal to 1.5. So all the parameters are there. You can calculate that calculation formula will be this one. No, the principal first लिख लिया. Calculation formula was D lambda by A, D lambda by D, but D lambda by A. Whenever you paste all the value, your answer becomes 18 millimeter. 18 millimeter, or you can convert into SI unit, that is 10 to the power minus 3 meter. 18 into 10 to the power minus 3 meter. The next condition. Give the condition of coherent sources of light. All of you know it. Light from two sources having intensity I. This question is to come. That light from two sources having intensity I and twice I cross each other with a phase difference pi by 3. What is the resulting intensity of two sources are coherent and incoherent? The resultant intensity for coherent sources, we know the formula I equal to root over I1 square plus I2 square, or that A1 square plus A2 square plus twice A1 A2 cos of phi. If you go through the intensity, that formula is different, that I equal to I1 plus I2 plus 2 into root I1 I2 cos of phi. Phi का वैल्यू दिया है pi by 3. इससे हम लोग कैलकुलेशन कर सकते हैं. और इनकोहेरेंट सोर्सेस के लिए क्या होता है? Directly sum up that I and twice I will be added. So if you compare it, then you see. Condition for coherent sources are two sources are of same frequency and they should have constant phase difference in between them. So coherent sources का condition याद रखना है किसी भी हालत में. The two sources should have same frequency and they must have constant phase difference in between them. और जो न्यूमेरिकल पार्ट इसमें देखो, रेजल्टेंट इंटेंसिटी इक्वल टू I1 plus I2 plus 2 root over I1 I2 cos of phi. तो इसमें वैल्यू बिठा देने से हम लोग का रिजल्ट आएगा इंटेंसिटी, रेजल्टेंट इंटेंसिटी 4.414 into I. और इनकोहेरेंट सोर्सेस के लिए I और twice I प्लस कर देने से I plus twice I equal to 3I. So this is the conditions for coherent and incoherent sources. Then two homework, I'm giving you. You can write these 2 points. One is the from double slit, both are from double slit experiment. One you have to find out the fringe separation. Another one you will find the distance between the two slits. Okay. So two questions are given for your self practice. Both are from Young double slit experiment. One, you have to find out what is the fringe separation. Another, you have to find out what is the distance between the two slits. Okay. So you write these two questions you write in your book, you try to solve by yourself. And this is a common formula beta equal to d lambda by small d. D means distance of the screen, lambda means wavelength of light, and small d is the distance between the two slits, and beta is the fringe width. So all the values are given. You can convert into SI unit and paste in the particular formula and calculate it. Okay. So all the students, once again, I'm saying you that due to some technical problem, it is not possible for me to take the classes on the interactive board. So I think tomorrow it will be possible. Tomorrow I will take your another next chapter, that is your uh, dual nature of matter and radiation, and I will give some more and more questions to you. So let us conclude this topic, wave optics, now. Okay, thank you. Thank you all, one and all.
Minimize करके तो साइड में इनका सिम कई बार बता दिए वो मेन वाला वही स्विच ऑन करना होगा सर।
हाँ, स्विच ऑन करना है।
वो स्विच ऑन करने से सब हो जाएगा ऑन।
हाँ, अगर आपको लैपटॉप से पढ़ना है तो कोई भी ऑन
कुछ भी नहीं, नहीं ऐसे ही पूछ रही हूँ, अगर पढ़ाना है बाय चांस वो भी तो पूछ के रखती हूँ।
पढ़ा नहीं तो चलो।
यही स्विच ऑन करना है, नहीं
ऑफ ये देखिए।
मामा क्या कहना है इसीलिए कल बढ़िया